Hey guys, welcome to week 6 of our quarantine. We're starting our acids and bases unit. Today this first video is going to be about intro to acids and bases, just kind of what they are, different types, how we name them, and therefore, we're doing a little different this time. I'm not going to write in all the notes. I have everything typed up. We're just going to talk about it and underline some key things. So let's look at our properties of acids. So dilute acids have a sour taste. Think like your vinegars, your citric acid, your lemons, your oranges, those kind of things. Those are all acidic, right? And they are aqueous solutions. Remember, aqueous means dissolved in water. And when they're dissolved in water, they become electrolytes. This is a key word here. So this means that they conduct an electrical current. This is based on the number of ions. So when we have strong acids, we have good conductors. When we have weak acids, we have bad conductors of electricity. So table K in your reference table, this is our list of common acids. If you look at this list, I'm sure you guys can pinpoint some ones that have stood out before. HCl should really stand out to you guys. Hydrochloric acid, sulfuric acid, this one here, as well as nitric acid. These ones should all be familiar names to you guys, whether it's from other science classes or even just watching movies and TV. All right, properties of acids continued. So when an acid reacts with a base, we get water and a salt. So this is our neutral solution. This is called the neutralization reaction, and it's very similar to the double replacement reactions you guys learned back when you did types of reactions. So let's put our arrows in here because it doesn't carry over. So when we have HCl reacting with NaOH, our hydrogen is going to come in and react with our OH, our hydroxide group, and form HOH or H2O. And then our chlorine is going to come over here and bond with our sodium, and we're going to have sodium chloride. Right, so we see that we have our positive from our hydrogen, our negative from our chlorine, our positive from our sodium, and our hydroxyl group is negative. Remember, that's a polyatomic ion. They come in, so we have our water and our salt. This is a neutralization reaction, and it is also a double replacement reaction, so we're able to predict the products as we go. So now let's take a look at Table J. Table J from our reference table is our activity series. So acids will react with certain metals to produce a hydrogen gas. So metals will produce a hydrogen gas when reacting with an acid as well as a salt. This is a single replacement reaction, right? So one swoops in, takes the place of the other. So any element in table J will react with an ion below it. So we're going to look at zinc, which is right here, and we're going to see what happens with the H2, right? So we have zinc plus hydrochloric acid. So zinc is neutral by itself, hydrogen is positive, chlorine is negative. So zinc is going to swoop in here and kick hydrogen out, and we're going to end up with zinc chloride. Let's put our arrow in there. And then hydrogen gas. Okay, so let's balance our equation here. We need 2 chlorines and 2 hydrogens on this side. Right? So single replacement. Zinc kicked hydrogen out, came in. We ended up with a compound and a single element here. Remember, A plus BC gives us AC plus B. Okay, so metals will react to produce hydrogen gas. Okay, and let's continue. So acids will cause acid-base indicators to change colors. We can see this in table M, right? So these are common acid-base indicators. We're going to talk about litmus right now, but we will also use other ones. I know I've mentioned it in the past that I used to work for Suffolk County Water Authority, and I did a lot of testing with alkalinity and pH and chemicals, and I used bromocreosol green during that time, and I was looking for close to this range. So not quite yellow, it was more of a greenish color I was looking for. If we hit yellow, we had gone too far. But let's go back to litmus paper real quick. So when litmus paper is put into an acid, it turns red. That's how we know what acid. And usually when we get into pH, we're going to talk about the indicators. There's a scale to tell you approximately what the pH is. But when you put blue litmus paper, if you see in the image here, it's a little bit blue on top. It turns red in the presence of an acid. So now we have this funky word here. We have an Arrhenius acid. So an Arrhenius acid is a substance dissolved in water, contains hydrogen ions as its only positive ion. So we're going to have H+. My arrows didn't carry over. All right, so here we have our acid, which is HBr. This is aqueous. And when it dissolves in water, we're just going to put water here above the arrow so we know we're dissolving it in water. We end up with H+, which is our hydrogen ion, or we can call it a proton. And we end up with Br- as well. So H+ can also be referred to as the hydronium ion, as H3O+, but we usually write it as H+ instead. So just a little breakdown example over here in the image. We have our Arrhenius acid, which breaks down into our hydrogen ion and our negative ion, whatever species that is that we're working with. So now we're going to name our acids. So binary means 2. We've discussed this plenty of times. So binary means 2. So binary acid, it's made of hydrogen and something else, typically a nonmetal. So let's look at our example here, HCl. So our first step, naming this, is we're going to always start with hydro. That's the beginning, right? Hydro, hydrogen. We're going to name the other element with the modified ending of ic. So we're going to change it to chloric. So step 1 was hydro. Step 2 was naming chlorine and changing the ending to ic. And then step 3 is we're just going to add the word acid to the end. Okay, so HCl becomes hydrochloric acid. Pretty simple with these guys, so we're going to do a couple practice ones. So I have HBr. So you guys can pause the video here real quick, take a shot at these, and then unpause and we can go through the answers. All right, so our first one, HBr. We're going to start with that hydro. And Br is bromine. So we have to change that ending to ic. So we're going to call it bromic acid. So hydrobromic acid. Our next one, H2S. So again, we're always going to start with hydro when they're binary acids. And S we know is sulfur. So hydrosulfic acid. And last but not least, we have HF. Again, start with that hydro. And we have fluorine, right? So hydrofluoric acid for HF. Very straightforward. The key thing here is to remember we always start our name with hydro when it comes to a binary acid. Because next we're going to talk about ternary acids. So a ternary means 3. So they always start with a hydrogen and they are attached to a polyatomic ion. Remember table E in your reference table. So there's a total of 3 elements in here. Now when we're naming these, we're not using hydro, so no hydro, all right? So if you remember from our polyatomic ions on table E, some of them end in ate, ate, and some of them end in ite, ite. So we name them a little bit differently depending on their ending. So for our polyatomic ions that end in ate, we're going to change the ending to ic, right? So if we have NO3, we have nitrate. So if we had HNO3, we would have nitric acid. So we're not doing hydronitric acid, it's just nitric acid. Now, For our polyatomic ions that end in "ite," we're going to change the ending to "-ose." So we have nitrite. So if I had HNO2, we would have nitrous acid. Okay, so a little bit different than naming binary compounds. You have to keep an eye out for what the ending is. Right, so if our ending is "ate," we change it to "ic." If our ending is "ite," we change it to "-ose." So those are our ternaries. Okay, remember binaries, hydro, change the ending of the second element, to "ic," and then add acid at the end. So we got a little flow chart here for you. This would be good to jot down in your notes just so you guys have an idea. Stem, the word stem here, this is referring to our other element, right? So if we had HCl, chlorine would be our stem. Okay, so just to break it down, whether it has two elements, we do hydro plus the stem or the other element plus "ic," and then we throw acid at the end. If we have a ternary or three, and they have a common ion table, so this is our polyatomic ion table. So this is table E. We change the ending based on whether it's "ate" or "ite," and then we add the word acid to the end. Okay, so 2 is binary, 3 is ternary. So let's take a look at bases. So these guys have bitter taste. If you've ever accidentally got soap in your mouth, you know that it's not very good tasting, right? So it's bitter. Soaps, antacid, baking soda, most of your cleaners, so your oven cleaners, Drano, those kind of things, those are all bases, and they have that slippery or soapy kind of feeling. They are also electrolytes, like an acid. So again, it depends on the concentration of ions, and if we have a strong base, we have a good conductor. If we have a weak base, we have a poor conductor. So it's easy to remember when something's a good conductor or poor conductor, whether it's an acid or a base, because your strong acids and bases are going to be good conductors, and your weak acid and bases are going to be poor conductors. So just like we had a table in the periodic table for common acids, we have one for bases as well. So table L in your reference table. This one should stand out to you guys, NaOH, sodium hydroxide. I'm sure you have seen this before in text or in practice problems here and there. But for the most part, these are going to be the more common bases that you see as we go along. So bases, like we said with acids, they react with one another to form a water and a salt in a neutralization reaction, also a double displacement. So let's look at the reaction of hydrobromic acid and potassium hydroxide. So we have a double displacement. So our hydrogen is going to swoop in and take the place of potassium, and we're going to end up with HOH, remember, or we can write H2O, your preference here. Then our bromine is going to come over here and bond with potassium. So then we're going to get potassium bromide. Right? This is our neutralization reaction. So we talked about indicators previously with acids. Bases work the same way with indicators. If you notice on this table M, from your reference table, these approximate pH ranges, they range, where's our lowest? Our lowest is 3.2 and our highest here is 10. We're going to talk about pH in the next video, but the higher the pH, the more basic something is. So these range from very acidic to very basic in the ability to indicate. So table M, again, litmus paper is going to be the one we're talking about right now because 8.2 is a very basic number. When litmus paper is in the presence of a base, it will turn blue. If you notice in the image over here, we have red or pink litmus paper. It is blue because it is in the presence of a base. So the opposite of an acid. But we're going to talk more about indicators and pH in the next video. So like we had Arrhenius acids, we have Arrhenius bases. So this is a substance that's dissolved in water, and its only negative ion is the hydroxide ion, or OH minus. My arrows didn't carry over. but that's okay. We'll draw them in. So if you see in the example below, we have sodium hydroxide. Remember, we're going to put the water right here just to say it's being dissolved in. Breaks down into sodium ion and the hydroxide ion. OH is the hydroxide ion, also a polyatomic ion. Again, with this image here on the bottom, you can see the Arrhenius base breaks down into some positive ion that it is bonded with, typically a metal. So this is going to be typically a metal. And it's always going to produce hydroxide as your basic species, as your negative ion. So, just like naming acids, there's different steps to naming the bases. So, these are a little bit easier. Our positive ion, this is going to be our metal or polyatomic ion. We keep the name the same. We name the base end with hydroxide. So, there's 3 examples here for you guys. What I would like you to do is pause the video to practice, and then unpause when you're finished, and we will go over the answers briefly. So, take a second now to work on these guys, and then come back. Okay, so our first one, we have NaOH. So our positive ion here is Na, and if you remember from your periodic table, that is sodium. So we're going to start with sodium, and then we're going to end it with hydroxide. Pretty straightforward here. Next, we have calcium, OH2, so it's going to be calcium hydroxide. And in our next one, you can see that we have a polyatomic ion as our positive. So we should remember, or we should be able to look back and know that this is our ammonium. So we are going to name this ammonium hydroxide. Okay, so the intro stuff for acid and bases is pretty straightforward. Remember that we have 2 types of acids. We have binary and ternary, so those with 2 elements, and then those with 3 elements, and their names slightly different. I do suggest looking at that flow chart and having that down in your notes. It's very helpful. When it comes to naming our bases, very, very straightforward. We use the metal or the polyatomic ion first, and then we throw the ending hydroxide on the end. Right? We are going to pick up in the next video with what is pH, and we're going to talk about the indicators more in depth and a little bit more about electrolytes and Bronsted-Lowry theory. So make sure you have these notes down and get working on your assignment, and we'll post the next lesson on Monday. So enjoy your next couple of days. Keep up on your work. If you have any questions, please do not hesitate to reach out to myself or Miss Anastasi. We are both in Google Classroom. I believe we're both in Remind. I will double check, but you should have both of our emails as well. So good luck and stay in touch.